looking at this graph, so I have this graph here, and I have this point here. So it says, this graph, the point passes through the graph. Does it make sense if I sub it inside? So I try, I sub minus half, negative half, half inside the graph, and I try to solve. The thing I want you to take note later is this part. Now, if I solve the one inside, do you agree is negative 3 over 2? But if I were to modulus it, then it will become 3 over 2. But why is it still minus? Why is it still minus? Oh, because the outside minus. So I will actually highlight this negative and this negative to tell you that the negative is not because of the inside. The negative is because the outside negative is negative. I copy it down, I bring over, and then A is 2. Hashtag. So this one no trick. Okay? Can you take this down first? Take this down. Then I prepare something here, I explain, then you take this down. Don't need to take photo. You can go to the video, then select certain point. Okay, I zoom in so that it's easier for you to copy. The bottom one no need to copy first. Just copy the top one. Let me know when it's done, then I tell you the next thing.
The bottom one cannot, alright?
Cannot.
No, because you see y is always positive, right? The graph can tell that y is always positive. So A will always be bigger than.
Bottom, wait first. You need to copy, but wait first. This part done already? Can, Okay, now, on your paper, you help me draw another line, like another column. Over here, I want to focus on these 3 examples. So, let me zoom in to, you find a space, probably under the graph. Let's try the first example, Now, if I have y equals to modulus x, y equals to modulus x, if I remove the modulus, what does it mean? Y equals to x, or y equals to, good. So I have 2 equations. So I have y equals to x, y equals to negative x. Now, why am I telling you this? Now, if I want to plot this, do you think this is one line or one v? With the modulus, 1v, do you agree? So I play cheat. I show you the graph. It's actually looking like this. Now my question, if I want to find this point, or rather, over here I got 2 equations. Do you think these 2 equations belong to these 2 lines? Yes or no? Again, these 2 equations, this one will be maybe equals to this or this. This may be equals to this or this. But definitely these 2 represent the 2 lines. Do you agree? How do I find the meeting point? What must I do? Start with S. Sub or C. Simultaneous. Agree? If I were to solve these 2 equations, can I find the meeting point? Can, right? Now look at this. If I have y equals to modulus x plus 1, can I split into 2 equations? How will I split? Can you try now? Y equals to modulus x, then outside got plus 1. If I were to split the 2 equations, can you write the 2 equations here? You write, I write, we compare. Try now. Okay, the first one looks something like that. What about the second one? Oh. So this one is y equals to negative x plus 1. What? Oh, 1 minus x, yeah. 1 minus x also can, minus x plus 1 also can. What I want to show you is the plus 1 here, 1 minus x also can. or minus x plus 1. What I want to show you here is the modulus itself will be so-called negative, but the one outside, you need to change the sign? Not affected, right? Now the last one, can you tell me this? How does it look like? 2 plus. So the first one will be y equals to 2 minus x. The second one will be 2 minus negative x, or 2 plus x. Is it like easy to understand? Okay, now you have two equations like that. Final test. Now, back to the question, original question. How do I split into two equations? Try to split. I show you the equation over here. You are taking down. So take down first. Then I show you the equation. That means the problem. Zoom out. Cover. Highlight. Frozen. Now look at this equation now. This is the actual question. How do I split? Can you split the two equations? This is the original question, right? A minus modulus x plus minus 1. So look at this equation now. How do you split? When you split, how does the two equations look like? Do now. No A. 2. The A is 2. Earlier on I found already.
What a negative?
Put a bracket, then it's easier, right? So minus bracket. X minus 1. Where's the X? No, 2. No, you cancel first. Cancel the original part. So it should be y equals to, look, copy this one first. Darren, 2 minus modulus, then the x minus 1 inside. Not sure, huh?
Just become the same. Only got 1 got plus.
One got plus, one got minus. Okay, I explain. Now, if I have an x minus 1, do you agree the first one is original, but it's positive? Okay, so it will look like that. Does it make sense? So the first one, the first one will be minus, but instead of modulus, it will be the positive of this, which is the original graph. Original x minus 1. But the other one, what happened? Why is it a plus? Because it's minus, then negative of this one. Okay, I write it out one step earlier, so it's easier to understand. Monisha, does this make sense? Because the first one is itself positive, but the second one is the x minus 1, now I take the negative. Because modulus I split, one is positive, one is negative. But the negative one, if I have two negative here, it will be plus. Then I can simplify here. What do you think I need to do to these two to find that point? Simultaneous. So solve simultaneous. What is the Q answer? 1. Is it 1, 1? I modulus? Good question. I'm waiting for that. If I modulus the minus 1, isn't it become 1? Answer is no. Why? Because there's a x inside. So you expand the negative, then it will be 1 minus x. 1, 2. So you solve simultaneous.
How you find Q?
Okay, wait. Okay, Ryan question is, how do you find Q like that? You solve simultaneous, you have x equals to 1, y equals to, Aisha, 2. What does this mean about x equals to 1, y equals to 2? This will be the intersecting point, intersection of these two lines. Is that Q? No? Yes. Look at the graph again. I have the pink line. I have the green line. Isn't Q the meeting point of the green and pink? So if I solve these two equations, isn't it telling me like last time, Sec 3, when we learned simultaneous equation, I solve these two simultaneous, I can find the meeting point. So I solve these two simultaneous. This is the answer. What does it mean? It's the intersection point between these two equations. And therefore, this point must be Q. Can follow? Oh, like only. Sure. Easy, right? 3-4 points like that.
The number 1 and number 2 is two different lines.
Correct. Number 1, number 2 are two different lines. Which one is which? I don't want to know. I don't need to know at the moment. But I know if I solve these two equations, it must be the intersecting point of these two lines. Okay.
How I know is the both of them is one line and the other one is another line.
How do I know? How do I know this one belongs to this one? I come back to here. Last time when I learned y equals to modulus x, I know that 1 is y equals to x, I know 1 is y equals negative x. Is there a one equation that can give you this? No, it must be two equations. It must be two lines like that. Unless it's a curve, then you can have one equation with one. This one, two straight lines must be two different equations. There's no way one equation can give you two different straight lines, right? So in this case, Q must be 1, 2. Some of you getting bored, turn over to the next page. What's the time now?
11.
11.